So we are trying to fill in our unit circle, and we learned a pattern yesterday for the radians. I like to start with all the multiples of 45. Does anybody remember what you did with the multiples of 45? You multiplied each multiple of 45 by...
whatever was right across on that line.
Oh, you're close.
6. That just gave me the answer.
40. This is how I'm at over 4. 45 multiples of 45 is pi over 4. They both start with a 4. So we're going to take all the multiples of 45. So we'll just jot that down again. Multiples of 45 times by pi over 4. Okay? So we start with the first multiple of 45, which is actually 0. And 0 times pi over 4 is still just 0. Okay? But then I have 1 pi over 4. And then I have 2 pi over 4, which is really just pi over 2. So there's 1 pi over 2, 1 pi over 4, 2 pi over 4, 3 pi over 4, which doesn't reduce, so it just stays 3 pi over 4, 4 pi over 4 over here for 180, but 4 pi over 4 is just pi. 5 pi over 4, 6 pi over 4 at 270, but that's really...
225 was 5 pi over 4?
Yeah. All the multiples of 45 we're doing. So this one is 6 pi over 4, which is 3 pi over 2. And then I have 7 pi over 4. And then when I go to 360, that's really 8 pi over 4, which is 2 pi. Okay. So there's all your multiples of 45 filled in. And then all I have to do is the same thing for the multiples of 30, except you multiply by...
18.
What? Multiples of 30, I times them all by pi over 6. That's all. That's my difference. So then now, remember your quadrantal angles, your 90, 180, 270, they're also multiples of 30. I already have their answer, but the pattern still fits, so it doesn't really matter when you fill in those quadrantal angles. So now when I start, again at 0, it'd be 0, and then I have 1 pi over 6. The next multiple of 30 would be 2 pi over 6, but that's just pi over 3. So 1, 2, this would be 3 pi over 6, but it's already filled in. 4 pi over 6. 2 pi over 3. 5 pi over 6.
Can we leave it as 4 pi over 6?
No. Yeah. 6 pi over 6. 7 pi over 6. 8 pi over 6 is really 4 pi over 3. 9 pi over 6. 10 pi over 6. And 11 pi over 6. And 12 pi over 6 for good measure gets you the 2 pi anyway. So there is how you fill in all your radians. Yeah, so if you know the pattern, they're not so bad. So multiples of 45, multiples of 30. So 45, remember it's pi over 4. You have the 4's in common there. And then this one's just a 6. So just remember that. Okay? And now all we have to do is fill in the ordered pairs. Did everybody already fill in your quadrantal angles? Were those easy enough? Because remember your radius is just 1. So if we're on the coordinate plane, if you're on a coordinate plane and this is the origin, isn't this 1, 0, 0, 1, -1, 0, and 0, -1? So now all I have to do, and we learned this yesterday, if I know these 3, I basically know them all because I just mirrored them all the way around and adjusted the signs. The problem is, do you know these first 3? You don't have to know them. I mean, it's convenient if you know them, but you guys have a reference sheet, and as long as you know cosine of your angle gives you your x value, and then sine of your angle gives you your y value, you have all of these because you have the sine and cosine of all these angles, right? It's right on your reference sheet. So just remember that it's cosine for the x and sine for the y. So when I go to fill in 30 degrees, I just look right at my reference sheet. 30 degrees, if I don't know it by now, sine of 30 is 1/2, cosine is √3/2. So the coordinate for this point right here, remember it's cosine first, √3/2, comma 1/2. And then I like to fill in 60 right now, because what do I know about this and this? Do you remember? Yeah, you literally just change x and y. So that was 1/2, and this is √3/2. And then the only one I have left to do is the 45s, but that's pretty easy. I just look at my chart. It's √2/2, and they're both the same, so you can't mess that up. Or I guess you could, but... So once you have these three, it's not that hard to fill in the rest because we remember everything is mirrored over. You do have to adjust the signs though, so positive, negative, depending on what quadrant you're in. So if we zoom out a bit, remember how the mirroring works. These two match up, these two and these two. So match, match, match. So this would be 1/2 √3/2, √2/2, √2/2, and √3/2, 1/2. However, since I'm in quadrant 2, who's negative? X or Y or both or what?
A.
All the x's are negative, so you must make sure that you make all of your x values negative.
This is easy.
I know! Once you get the pattern down, it's really not bad. Alright, and then I'm going to do the same thing for the third quadrant. Remember how the pattern works? These two will match up, then these two, then these two. Right? So closest, middle, furthest out. Okay, so I just copy those, √3/2, 1/2. However, yeah, everybody's negative in quadrant 3, so make sure that you make your x's and your y's negatives. You cannot forget that important piece. And then I do the same thing for my fourth quadrant, mirror, so those match up, closest, middle, furthest out.
Let's go.
Who will be negative in quadrant 4? The y values, correct. And I highly recommend that when you're done, just double check yourself and match up these. So just make sure that these line up because you've gone all the way around if you made a mistake. So these two should be the same. Just the signs are going to be different, right? Same and same. Yep. And then you are done. And then you have this beautiful circle chart all filled in that when you do this tomorrow, it's not only going to count as a quiz grade, so you're going to get 100 as a quiz grade because you know how to fill this out, but then I'm going to let you use this on the quiz and test for this chapter. So that's so much less work that you'll have to do if you have this in front of you. Yep. I can, but in case if I forget, it is in your book on page 111. What an easy number to remember. So there you have your same thing. Page 111 in your text. All right, so what do you think? Easy enough?
Yeah.
Now that you've done it once or twice?
Yep.
Okay. So let's stop the video here.